It's a hobby, right?
Yes, it's just fun stuff. Yeah.
Okay, so I'm very happy to have Clément.
Clémence.
Clémence.
Thank you.
And Clémence will present their hobby operating system called skiftOS, and I'm very happy to hear about it.
Thank you. So welcome to my call. Does everyone hear me well? Okay. So I had always this question of what happens when you design and implement the entire stack? Because I kind of have like this obsession about operating systems from like when I was really young. So I started building like operating system in like Visual Basic. But now I got a bit better at it, and now I build them in C++, I guess. So quick information about me. So as he said, my name is Clémence. By day, I mostly work on a browser engine. But by night, I like to hack on operating system. My website is smnx.sh, but everything was in the QR code, and I will show it again at the end of the slides. So what are we talking about today? We are going to talk about my hobby operating system called skiftOS. It's aimed to be this kind of general-purpose desktop environment and operating system. And it's based on a microkernel, and it features what I will mean a rich C++ framework. And obviously, I hate POSIX, and I will fight against it. So what are the goals of this project? Mostly it's about having fun and learning, but maybe do a bit of research and try some new stuff. So what is the current stage of the project? Is mainly really early stage. Most components are mostly like proof of concept, meaning that I've basically like written like the 10% of the code that provide like the 30% of the features. It's in total around 100,000 line of code, and it features a full desktop. And so from now on, this talk will follow the boot process of the operating system, and we'll stop at each stages, and we will discuss what each of the components and what they do and how they work. So I have included the build stage in it because building an operating system is already kind of complicated. So I will then we'll talk about the handoff, so from the platform firmware to the operating system, how we handle that, then init system, and finally what happened during the runtime of the operating system. So during the build time, we'll talk about the build system called QtKit. So what is QtKit? Is this kind of a cargo-inspired build system and package manager for C++. It's brutally designed for C++ modules. And it's, I will mean like it's battery included, meaning it will support all the life cycle of your software, meaning it can do linting, fusing, profiling, and obviously building your project. And what is the main idea between QtKit is the QtKit component. A QtKit component is like a loose bag of code and data and a manifest that describes some piece of the operating system. So for example, here I have a component called carm.sys.skift, which is the skiftOS implementation of the Carm system framework, meaning it's the abstraction over all the system APIs. And to describe this component, we use these JSON structures. So on the top, we have like the name of the component, what kind of component in it. Here it's a library. And then we have like this tiny predicate that tell, this component will enable only if it's in the system is skift. But as you can see, it's a list, so it's kind of a whitelist kind of thing. Then it will tell what is required. For example, here it will require the C runtime, and it will provide carmsys.impl, so the implementation of carmsys. And we can have like multiple implementation. For example, we can have like carmsys.posix that will abstract POSIX under carmsys. Okay, so since we started to see Carm through QtKit, let's continue with Carm, because Carm is really at the bottom, at the foundation of the whole operating system. So what is Carm? It's tried to be like this big general purpose library, kind of like a Qt or like the .NET framework, meaning that it will try to support everything like from basic data structures up to a full GUI applications. And And it's split mostly into two parts. The freestanding part of the library, which means like it's this part of the library that doesn't require any operating system, that can be shared amongst all the other components, and the mostly hosted part that require an operating system, mostly like for doing UI libraries and UIs and stuff. And it takes inspiration again from Rust, Go, and C#. I see the question coming about Rust again. So, and it's not written really in C++. Well, it's written in C++, but it's really like this calm flavored C++. So you know the meme like C++ with C with classes. Me, I prefer like C with lambda modules and coroutines. We don't use exception because since we want the framework to work at a really low level, well, exceptions are not available, so we use a monadic error handling with a result type and a try macro. And we make use of all the Clank safety check we can use. For example, we use a Clank lifetime bound to check that a reference doesn't outlive the object that it is being owned for by. And we use unsafe buffer usage. That is kind of like unsafe for C++. Meaning you cannot use raw pointers anywhere in the operating system. It can only be done in like some kind of unsafe block kind of thing. And so this is what an hello world in CARM looks like. So this is just an hello world in user space. So you can see we have like beautiful C++ modules. And another really nice specificity of CARM is that it's fully async by default, meaning that your entry point is an asynchronous task. And this asynchronous task takes two objects. That is a system context and a constellation token. This constellation token kind of works like a SIG term in POSIX, meaning that it will get triggered and try to cancel every downstream task when, for example, the user asks the kernel, yeah, kill this, I don't want it, it's spinning or it's bugging or something. And here I have just like a basic hello world application, so it just does UI run async, and then we pass it just a UI label with hello world. And it's kind of a Swift UI slash Jetpack Compose Inspire UI library. We might see a bit more after. And obviously, since we are in the microkernel dev room, we might care more about RPC. For now, we don't really use an ideal language. We use these C++ structs, where you just declare like your message. Then in this message, you have a type that represents the response, and then you have the parameters. And we use the quite limited, not for too long capabilities, reflection of capabilities of C++ to try to generate code around this. How do we use this? Is that you just have like to create an IPC client, tell it to connect to some kind of IPC endpoint. For example, here it's Strata Shell, which is our UI server. And then you can just call it using client.call async, and all RPC are asynchronous. So it will just return some promise that can be awaited, and then we can continue. And obviously, no exception, we use again this kind of weird macro called cotry. That kind of, it's a specialization for a coroutine, but that's not too much of a detail right now. Okay, so now we saw the base of the framework. Let's talk about the bootloader. So the bootloader is not really, it's a simple UEFI bootloader, and it uses, I will follow my slides. So it's this simple UEFI bootloader in kind of work like a systemd boot, where it's basically just chain load like either like UEFI executable, or it can load a new ELF file and then jump into it, which will be your kernel. It has its own tiny boot protocol called handover, which is basically just a memory map with some added attributes. For example, you can have like a range of memory, and to this range of memory, we attach some metadata like, oh, this is a frame buffer and this is the size. But it's quite limited in this way. Oh, yeah. And finally, the bootloader uses exactly the same UI library as the rest of the operating system, meaning that we get all these beautifully beautiful vector graphic with subpixel anti-aliased font and such. So it's really nice. Okay, so we saw the bootloader. So the bootloader will load a new component called the Earth microkernel. So what is the Earth microkernel? It's what some people might call a pragmatic microkernel, meaning that we don't strive for academic purity in it. It's quite small and simple. I think it's good for learning, I guess, because it's pretty simple, but it implements everything a microkernel should do. And it takes care of core kernel responsibilities, which by this I mean IPC, preemption, memory management, and IRQ dispatch. And it has a quite simple object model. I won't describe all of them, it will be quite boring, I guess. And it has around 25 syscalls. Some people say it's better to have less or more, I don't care. Okay. To get a bit more of a vibe for the code in the kernel, let's look at the send syscall, meaning the syscall that it's used to send an RPC message. And as you can see, it's written in a really idiomatic C++, I would say. And we use C++ to make this code quite safer. For example, here we have a buffer that comes from user space, and every buffer and data that comes from user space is wrapped in this user slice type. And you cannot access this type up until you have like kind of differentiate it with the with function. And this with function takes an address space, and at the bottom it takes everything you want to access, and we make sure that everything is mapped correctly, and that the user space cannot like move data around or do nasty stuff with your memory. And then in the body of the function, we see that each task is attached a domain, and in this domain, we'll try to get a channel based on the capabilities, and then we use this channel to send the message and some capabilities with it. So that was everything for the Earth microkernel. Now the next step is the Strata service layer. So now we exited the kernel space and low-level stuff, and now we enter the system level stuff. So Strata is kind of a loose bag of services, and how do we enter Strata? We enter it through Strata CM, the Strata Component Manager. The Strata Component Manager is loaded by Earth or microkernel as the first executable, and it will then directly delegate to a process called Strata Ini, which is our init system, that will then read a bunch of manifests and spawn a bunch of services. But what are those services? So at the bottom we have Strata Component Manager, as we say, and then we have a Strata device that is for now kind of a big service that all of our device driver. We might change that later, but right now it's like this. Then we have the Strata file system, which all our virtual file system and how we access it. Then we have a Strata input that take a raw HID event from the Strata device and then turn them into something that the UI can better understand. It's kind of like iBus kind of thing. And then we have a Strata shell, that is our user interface. But to discuss it, I prefer going into the next chapter. Then we have application on top. So the next chapter is about the IDEO desktop environment. And what is IDEO? Is this kind of general purpose, like a user interface. It's built on a custom display protocol, and like it's kind of like Wayland but way simpler. And it has what we call an adaptive UI, meaning that this UI can scale from like a smartwatch up until like a full desktop environment, and all the app will be the same, and they just like scale on based on what the device is capable of. As we say with the bootloader, it has the same vector-based, some subpixel alias, and with beautiful fonts as the rest of the operating system. Okay, so that was it for the general architecture of the operating system. Well, not all of it, because all we know is that operating systems are just bootloader for browser engines. So, Skift has its own browser engine that is called Wave, and Wave is not really part of the general project. It's kind of more like my daytime work that I have ported back to the operating system as a fun project, I guess. And it's like a full browser engine, meaning that it has like HTML and CSS. It can render like some web pages. I will show them during the demo. we don't have JS for now, and I think it's pretty fast. So, demo time. So, up. So, I will use, obviously, Qt to boot my operating system. We'll do a bunch of Ninja invocation. Then we have like, yeah, it booted at least. Don't look at the time. I didn't have the time to implement RTC. Okay, I can just look at my display, I guess. I want to full screen it. No, it's not this. Okay, so it has like a normal UI we will expect like in a normal operating system, so I can unlock it. And let's look a bit of some application. So first of all, we can like look at, I don't know, like we have like basic like calculator stuff. It does math, obviously. But you can like switch in like into tablet mode, and then it will just like adapt the UI for the new form factor, and you can switch easily like this. And then I can close it. Nothing fancy here. Then we can look at the web browser. So I took some snapshot of a website because we don't have a network stack yet. But we can look at the home page of the internet, I guess. Ah no, not this one. This one. Yes, and okay, I will go back to Google because maybe it will be a bit more interesting, but maybe, no, it doesn't work. I cannot resize. Okay, it's okay. But you can see that the browser is kind of capable. We don't have like the logo, things that are not aligned, but it's quite nice. Okay, and so maybe I can show you another thing. And it crashed, I guess. Okay. Sorry about that. Okay, we are back. We are so back. Okay. Okay, and obviously, it can run Doom, I guess. Yeah. Fun fact, it will go faster if I go into like tablet mode because it doesn't show the rest of the UI. Yes, because we don't have like a GPU acceleration. Everything is on the CPU. So, but I can play a bit of Doom. I'm not sure if I'm good at it, so I should be good at it. Like. All the old men here will be screaming, I guess. But I can kill bodies and some stuff. Yeah, that's the thing.
You have like any audio?
No, we don't have audio yet. Audio will be pretty funny, but well, to be fair, Carm does support audio. We have like basic audio stuff, but I didn't hook it up into. No, I won't do that. I won't spoil people.
You mean motherboard speaker?
Hmm?
You mean motherboard speaker?
No, I lost. I was playing. Okay, so we have like the framework supports it, meaning if I run it in like if I run Carm on Linux, I will get like audio and stuff. But in Skiff, I don't have like audio card driver. Okay, then I'm done by this. Okay. Other thing. No, it's not the SDL version. It's a port called Pure Doom that is meant to be easily ported. We don't have like a third-party software running because I said at the start of the call I will not support POSIX, at least directly. So it's a bit harder to port software. Okay, I will show you another demo because I told you that everything is based on Carm, and Carm can be ported to any operating system. And do you know another operating system? It's called UEFI. And let's say I just change like where it is. I think I have some time, so I not have to rush. But let's say I replace like the name of the bootloader by another software called VE browser.main, I guess this one is called. Let's see if it works. Why? I'm not in the right directory. Let's wait. I should have like pre-built it, but it's pretty fast. C++ module baby, I guess. Sorry about that. I had the ID just before, so. Hey. It's kind of ruined the timing of the joke, I guess. Okay, it's coming. Yeah, browser in UEFI. And I think I will go back to my slides now. Okay, so beyond. I kind of want full Virtio support because since Virtio has like every device class, it will mean that we can like build the rest of the operating system without being having like the first step is like porting the NVIDIA driver. So it will be simpler. Networking, obviously. On the disk file system, I have like my eye on like a GFS because it's quite simple and seems interesting. Sound server, I don't remember who talked about this. Namespacing, because right now everything is like in this one big namespace, but I think it's just a ref pointer away from having like namespaces. And HTML and CSS in the bootloader. Well, I'll show it. So you got already a boot. Well, it's actually like a real idea. Like you know, like Unix porn and the people that try to rise their bootloader and stuff. I think they will love this one. So that's about it for my talk. So I have some special thanks. First, I want to thank Mathilde because she's my girlfriend and she kind of forced me to do this talk, but I kind of enjoy it. I also want to thank Lou here, which is my coworker, and with her I'm working on the browser engine. And I want to thank Jordan because it worked a lot of CuteKit and also all of the DevSC Discord server and OSDev Discord server because it was fun to show my stuff there and get their feedbacks and stuff. And obviously, all of you for watching this talk. Thank you.
That was very much a lot of fun.
Thank you.
So any questions?
On what architecture?
Mostly x86. Oh, yes. Which architecture do it run? It's run mostly on x86. I think you can just like boot kind of the operating system in like RISC-V, but not yet. Thank you.
And does it run on real hardware or do you use QEMU right now?
I don't see why it will not. Since we use like we might not have like a keyboard interface and mouse because we don't have a USB stack, and we rely on the PS2 fallbacks they can do. So we will not have like real hardware. Maybe you can have like the boot screen working.
Okay. So that means I can get it on real hardware if I have PS2.
Sorry, I didn't
I
understand.
have PS2 in my hardware, so.
So the question was, if you have PS2 on your hardware, it will work, I think, except some minor issue.
Okay. You mentioned that the Windows server has custom protocol.
Yes.
Does it do client-side rendering as it is used today?
Yes, it's a fully client-side render. As you can see, Doom doesn't have like the bar on top because I didn't have the time to shrink it down and leave some space for it. Question?
And that was the UEFI frame buffer, right? The one that we saw.
So the question was, is this the UEFI frame buffer? Yes, it was using GOP to access the frame buffer.
What security mechanisms does your microkernel support? Do you have capabilities or anything like that?
So the question was, what are the security measures in the microkernel? The only security is like whatever is guaranteed by having the processes isolated in different page tables. And the capabilities, we have like a handle table to everything that each task can access. Like each task has like a domain they can like index into to find pointers to other objects. It's pretty simple. And then domains can be like they can kind of represent a tree, so you can index into the domain of another task if you have a capabilities to the domain of this task. So this way you can like prepare the environment for another task and then spawn it, which is pretty simple textbook stuff, I guess. Yes?
Yeah. You mentioned it, but I didn't get it quite well. Is it possible to run your UI library on Linux or?
Oh yes, okay. So the question was, does the UI library run on Linux? And yes, it works. It works everywhere because I can like show it quickly. I can, since I'm on Linux, I will have internet, so I can show my website also. HTTP. Up. I cannot type, I'm too stressed, sorry. So I will just, okay, I lied. Okay, it does not work, I don't know why. Okay, I can, yeah, you see, it just works on Linux. And, yeah, voilà.
I get the same question, but I want also to ask, like, what's the, like, how do you manage the state in the...
okay, so the question is, how does the state management work? So is this like a really hype and trendy way of doing it? So it's, where is it?
And like skiftUI.
Yes, it's mostly like a Helm architecture. Which one? I have like these fonts. Oh, you don't want to show me it to me? Okay, I guess. Does I have the counter? Yes. I just wanted like, you just implement like this basic state system. And then you have like messages, and then you have like a reducer that applies the message and the state at the right time. So it's pretty modern. Like it's kind of inspired by React and Redux kind of thing, and other libraries in the same vein.
All the way in the back.
What type of the UI can user can use any type of IPA to create different components?
So the question is, no, I didn't understand the question. So, okay.
Can you create custom components with the UI framework?
Can you create
Okay. Can you define? Okay, if I understand the question correctly, can you define your own component for the UI library? Oh, yes. It's just a class. You have to subclass, and then you can do. This is for like low-level stuff, and then you can like compose them together and assemble them together. So for example, I have like this is like the sample counter application. You're on the back, so you might not see it well. So maybe, but it's just like I don't know how to describe it, but you can assemble stuff like you will do in React. And if you have to do like a low-level like event routing or painting stuff, you can just subclass the UI node class, and you can do whatever you want in this. It's not like there is no second class, first class. You're always in first class. Do stuff.
One or two more?
Yeah, one question. You say that you have the 20 syscodes implemented, right?
I didn't understand.
The syscodes, you have implemented several syscodes. So my question is, did you manage to implement your own libc, or you bought it from one?
We don't use any we don't use a libc. Well, we have like a basic libc because the compiler requires it.
Okay.
So it's just like some basic string function, but it's really simple.
You didn't talk to anyone, so you can't run maybe software written code Linux, or even it's even the simple one on.
Right now, Doom use some of the classic APIs, but right now no. But I think it will be kind of complicated since everything is like using this C++ coroutine. So you will need to find a way to translate like asynchronous call into a synchronous one. I don't see a blocker, but we didn't work on it yet.
Okay.
The last question. Anyone? I asked him what's this nice font here.
Oh, it's comic sans MS but monospace. I don't know, my brain can only read the comic sans MS, so it's probably because of school, so something like this.
Well, thanks a lot.